Welcome all of you to our next method of electrochemical method of analysis. We already studied our two electrochemical methods of analysis, potentiometry and conductometry. Now, we will study our next method of electrochemical analysis, that is polarography. So, I welcome all of you to have a look on polarography. What is polarography? The principle, the contents include principle, Icobic equation, construction and working of dropping mercury electrode and rotating platinum electrode, and the applications of polarography. Polarography as a science is a method of electrochemical method of analysis in which it is a subclass of voltammetry. Okay, it is a subclass or subtype of voltammetry where the working electrode, like a dropping mercury electrode, is dipped, or a static dropping mercury electrode is dipped in the solution, and it is very useful. It is very useful for wide cathodic range and renewable surfaces. So, this is the one positive thing for polarography estimation if we use a dropping mercury electrode, because you will every time you drop a mercury, you will get a renewable electrode surface over there. Polarography is an electrochemical method of analysis which is based on measurement of current flow. We measure the current flow with the diffuse current resulting from the electrolysis of the solution under study or the analytical solution under study with a polarizable electrode or a microelectrode. It is a type of microelectrode which is a function of applied voltage or applied electrode potential. So, we measure our diffuse current with the function of applied voltage or applied electrode potential with the help of a microelectrode. There can be two types of microelectrode, a dropping mercury electrode and a rotating platinum electrode. A dropping mercury electrode, we get always a renewable surface as the mercury drops over inside the solution. We get a new drop of mercury which serve as a renewable surface of electrode or a new microelectrode. It is a very good or very well known method of electrochemical analysis. It is a method of analysis in which a sample is subjected to electrolysis. Electrolysis सैम्पल जो हमारा एनालिटिकल सोल्यूशन है उसको हम एक इलेक्ट्रिक फील्ड अप्लाई करके इलेक्ट्रोलाइसिस करते हैं यूजिंग अ स्पेशल माइक्रो इलेक्ट्रोड एंड अ रेंज ऑफ अप्लाइड वोल्टेज. A range of applied voltage. A range of applied voltage, what does it mean? Applied voltage ranges from -2 to +9. Okay, this -2 to +9 volt range of voltage covers both type of microelectrodes, the dropping mercury electrode as well as rotating platinum electrode as well. Using a special microelectrode and a range of applied voltage, that is why because of this wide range of applied voltage, this science of polarography is easily useful for most of the electrolytic solution. When we applied electrolysis to such electrolytic solution, electrolysis is being done which generates an applied voltage, and applied voltage generates a diffusion current. Then we can plot the diffuse current against the voltage or applied voltage, showing in this graph corresponding to the particular chemical species or the particular ions or particular analytical solution which is proportional to the concentration of that analytical solution or concentration of that ions, as we all can see there. This is our polarogram. This is the applied voltage with the help of microelectrodes. And this is the current generated, diffuse current ID. Okay. this is the current generator, this is the half diffusion current, this is full diffusion current, and this is limiting current. So, this is our polarogram. So, we can see what is total principle of polarography, or what does the polarography mean. It is a method of analysis of, it is a very good method of electrochemical method of analysis, in which a sample is subjected to electrolysis using a special micro electrode. Yes, it is a special micro electrode, and it can be applied on a range of voltages. The range of voltage is very high. It has a wide variety of range for both the micro electrodes, dropping mercury electrode as well as rotating platinum electrode. Then during the course of titration, a plot of current generated is plotted against the voltage applied, which is directly related to a particular chemical species or the analyte under study or our analytical solution or test solution. From there we can easily know the concentration of our analyte or the concentration of our analyte or our analytical solution or our sample solution. So, this is all about polarography. Then comes principle of polarography, which is also called as polarographic analysis. It is a method of electrochemical analysis or voltammetry. It is also called as voltammetry in analytical chemistry. The simple principle of polarography is the study of concentration of solutions of majorly either oxidizable or reducible substances by the means of electrolysis with two special electrodes, out of which one can be polarizable and other unpolarizable. This is the principle of polarography. In polarography, we use two sort of electrodes, and most of the solution which are under study or most of the analytical solution which are estimated with the help of polarography mainly includes oxidization, oxidizable and reducible substances, that means oxidants and reductants mainly. Okay. Then there we estimate the amount of current being generated, which is directly related to the applied voltage, and we plot a graph over there, which in terms relates to amount of our species or the type of our charge species, which is related to the concentration of analyte or our analytical solution. Moving ahead, polarographic measurements are governed by Icobic equation. What is Icobic equation? Icobic equation is a linear relationship. As we can see, it is a linear relationship between the diffusion current ID and the concentration of electroactive species. This term is very important, electroactive species. If the species or the analyte which is under study will not be electroactive, then it will be very difficult to estimate or to determine the concentration of such analyte with this method of polarography. For this method of polarography to work out for any kind of analytical solution, the analytical solution or the analyte under study or our sample is to be electroactive. Electroactive species is shown by Icobic equation. This polarography means this Icobic equation governs this polarography, which means our generated current, our generated diffuse current, as we saw in our last graph. This graph, this is the generated diffuse current, which is directly related to the applied voltage and which in turns is related to the concentration of our electrolytic species in our sample. The linear, it is an Icobic equation is a linear relationship between the diffuse current and the differentiation and the concentration of electroactive species, which is shown by the Icobic equation. This is the linear relationship, as we all can see. This is the ID diffuse current is equal to K into N into C, into d raised to 1 by 3 m raised to 2 by 3 and T, which is temperature, raised to 1 by 6, where K is the Faraday constant, ID is the diffused current, N is the number of electrons per molecule of electroactive species. N is the number of molecules per molecule of electroactive species, means number of ions, number of charges of number of electrons which are being generated, number of electrons which are being generated from that electroactive species or that particular analyte. D is the diffusion coefficient in square centimeter per second. C is the concentration of our analytical solution in millimoles. Then M is the mass of mercury dropping in ml per second in dropping mercury electrode, and T is the time for drop in seconds. So, this was all about our Icobic equation. I will tell you once again, I will revise it once again. Icobic equation is a linear relationship which establishes a linear relationship, a direct relationship between the diffuse current generated and the concentration of analytical solution. This is the concentration of analytical solution in millimoles per second, and this is the diffused current. Here you can see very well, all are directly proportional to the diffused current generated. You can see very well in this formula of Icobic equation. So, all of you, this was all about Icobic equation. Icobic equation is used to determine our diffuse current, through which we can determine our concentration of ions or concentration of analytical solution from this particular relationship or particular equation or Icobic equation formula. Then moving ahead, what are the types of electrodes which are being used? What are the types of electrodes which are being used in polarography? How do they work? What is their instrumentation, functions and advantages? Let us study in detail. Mercury electrodes. Polarography includes mercury electrodes, mainly a dropping mercury electrode. Dropping mercury electrode is a working electrode arrangement where mercury is used as a working electrode for polarography, in which mercury, point to be noted, mercury continuously drops from a reservoir of mercury. There is a reservoir of mercury through which mercury continuously drop from a capillary tube with the internal diameter of 0.03 to 0.05 millimeter into the solution. The optimum internal drop for most analysis is between 2 to 5 seconds. So, this is the specification of dropping mercury electrode. Dropping mercury electrode drops from a mercury reservoirs with an internal diameter through a capillary. Capillary should have an internal diameter of 0.03 to 0.05 into the electrolytic solution or solution of our sample or analytical solution. The optimum interval between drops for most analysis is between 2 to 5 seconds. There should be a gap of 2 to 5 seconds between one drop to drop and second drop. Before the commencement of second drop, there should be a gap of 2 to 5 seconds. So, this is the specification of how a mercury dropping electrode comprises of. The unique advantage to use the dropping mercury electrode is that the constant renewal of the mercury surface, as I told you earlier in this present lecture also. In DME, dropping mercury electrode, when a new drop forms, it drop down, then before it gets sufficiently charged, and over that a new drop forms. Thus, that particular new drops work as a new micro electrode, because it does not gets coated over the by the charges or the ions before the ions or charges forms over there, provides a coating over that particular mercury drop, it falls down or it drops down, followed by the generation or formation of new mercury drop. So, that is why this is the most advantageous point of this dropping mercury electrode. This is the most useful thing for this particular dropping mercury electrode is its renewability. It can be renewed during the course of titration, and it can renew its surfaces again and again, serving as a new electrode once again. The electrode surface exposed to the test solution eliminates and the effects of electrode poisoning. When it renews its surfaces, the constant renewal, this is the important point for DME, the constant renewal of dropping mercury electrode surface exposed to the test solution eliminates the effects of electrode poisoning. By this reason, because of this thing, this renewability which a dropping mercury electrode has, it works like a new micro electrode during the course of titration at several instances throughout the titration, and it bars from the electrode to get poisoned up. What is electrode poisoning? Electrode poisoning means deposition of ions or deposition of layers over the electrode, which bars or impacts the performance of electrode and its connectivity or its conductance with the electrolytic solution in which it is being dipped up. So, moving ahead, what are the types of mercury electrodes? Types of mercury electrodes includes first type, hanging mercury drop electrode. In hanging mercury drop electrode, we extrude the drop of mercury by rotating a micrometer screw that pushes the mercury from the reservoir through a narrow capillary, and capillary have the dimension of 0.03 mm to 0.05 mm. Dimension we already studied in our last slide. Here mercury drops from a reservoir, as we can see here, this is the reservoir of mercury. The mercury drops from in there. Okay. The next type of mercury electrodes, here you can see how a mercury drops and a new droplet is formed again and again. You can see here very well. In this way, it draws from the mercury, reservoir. So, it leads to a formation of new electrode again and again. Next type is dropping mercury electrode, DME. Mercury drops from the end of a capillary tube as a result of gravity until, unlike the HDME, hanging mercury drop electrode, the mercury drop of DME grows continuously as mercury flows from the reservoir under the influence of gravity and finite lifetime for several seconds. It is a continuous method of dropping mercury from the capillary, and this is the difference which is being seen from hanging drop mercury electrode. Next one is a static mercury drop electrode. It uses a solenoid driver plunger to control the flow of mercury, and activity of this solenoid momentum is being monitored up by the mercury drop which drops out inside the solution, allowing the mercury to flow through the capillary and forming a single hanging drop which remain static throughout the process. This is the difference between a static mercury drop electrode. Here no new drop forms, it is a static mercury drop electrode that forms, which remains static throughout the process, and it is the single drop which works as an electrode throughout the titration, but here new drop renews during the course of full titration of polarography. So, moving ahead, in polarography, mercury is used as a working electrode because mercury, it is a liquid which often drops suspended from the end of a capillary tube having a dimension 0.03 mm to 0.05 mm. Mercury is very useful as a dropping mercury electrode. Why mercury is only used as a dropping mercury electrode? Because it displays a wide negative potential range. It displays a wide negative potential range, as I told you earlier also. It displays, it is applicable, polarography is applicable over a wide potential range. Its surfaces are readily regenerated by producing a new drop or film. Its surfaces are readily regenerated, so a new drop or a new surface will again serve as a new micro electrode. Then many metal ions can be reversibly reduced into it. Many metal ions can be easily estimated, can be easily determined very well by this method of polarography. So, this was all why mercury is being used up in this method of electrochemical analysis. So, why mercury is being used up? Because mercury serves as a dropping mercury in electrode, as many metal ions can be reversibly estimated also. Mercury serves as a very good dropping mercury electrode, because every time a new drop falls out, a new electrode, micro electrode is being generated as a new drop, and new drop serve as a new micro electrode with a new surface of mercury over it. It gives very accurate results. It is readily generated by a new drop of mercury. It displays a very wide potential range, electrode potential range. So, this is all benefits which we get by using mercury electrodes or a dropping mercury electrodes. Then, what are the applications of polarography? What are the applications of polarography? Since we all know that it is the electrode comprises of mercury, thus a mercury dropping electrode can be very well used for the analysis of various metals such as zinc, cadmium, etc. It can be used for the very well anions also, like bromate, iodate, analysis of carbonyl groups also, peroxide, nitro, azo group. Thus, it can be very well used for the estimation of biochemical fluids in biochemical analysis for various physiological solutions or biochemical solutions in patholabs. Thus, these are the all applications of polarography in generalized application of polarography: estimation of metals like zinc, cadmium, etc., analysis of various ions or various anions means negatively charged ions. Analysis of various anions or negatively charged anions means bromate, iodate, etc. Analysis of carbonyls, peroxide groups, nitro and azo groups, etc. Peroxide groups, etc. means we will study these application in detail in our next subsequent lectures, coming lectures. Then next come our biochemical analysis. Biochemical analysis means analysis of physiological fluids or biochemical fluids can be very well estimated or very well analyzed by this method of analysis. So, we can summarize this method altogether now. What is a polarography? Now we can know, now we can summarize it very well. Polarography is a polarographic technique or voltammetry. It is a very good science of electrochemical method. It is a very good electrochemical method in which we determine the diffuse current. Diffuse current is determined with the help of this graph ID. You can see in this graph, we can determine this diffuse current and plot it against the applied voltage, which in turn will give you the concentration of analytical solution or concentration of our test solution with the formula, with the relationship, a very well known relationship, linear relationship, that is known as Icoic equation. We have already studied the Icoic equation. This is the Icobic equation. Icobic equation is ID is equal to K into N into C into D raised to 1 by 3, M raised to 2 by 3 and T raised to 1 by 6, where K is the Faraday constant, ID is the diffused current, N is the number of electrons of mole of molecule in a molecule in electroactive species, D is the diffused current or diffusion current which is being generated over there, C is the concentration of millimoles, concentration of our analytical solution or our test solution in millimoles per liter. Then M is the mass of mercury dropping from the capillary, is the mass of mercury dropping from the capillary. Then T is the time to drop in seconds. So, this was all Icobic equation, which is a linear relationship between the diffusion current and the concentration. It is a very good relationship between the diffusion current and the concentration of our electroactive species or the analytical solution which is to be determined. So, altogether now we can easily summarize our polarography. Polarography is a science of voltammetry or is a technique of electroactive determination in which we know the diffuse current, we used to calculate the diffuse current from Icobic equation, through which we can know the applied voltage, the voltage which is being generated up, and we can plot the graph for both as one in x axis and one is y axis, and from the linear equation Icobic equation we can know the concentration of our electroactive species or the concentration of our analytical solution. So, this was all about polarography. So, it is a very simple method of electrochemical analysis or voltammetry in which voltage and diffuse current can be determined very well and which in turn can be used to calculate our current, calculate our concentration of analytical solution or our test solution. Mainly this method is applicable for the determination of metals, means oxidizable substances and reducible substances. So, this was all about polarography. It is a very good electrochemical method of analysis which gives very good accurate results. Then the graph which is being plotted up, we called it as a polarogram. This is called it as polarogram. This is the Icobic equation which is used to calculate the concentration of our analyte, of our sample through the calculation of diffuse current and the voltage. Then the electrode which are being used up are of two types, mercury electrodes which is again are of three subtypes, which have again three subtypes, and a rotating platinum electrode which we will study in detail in our further lectures. Dropping mercury electrode is of again three types, hanging mercury electrode, then dropping mercury electrode, then static mercury electrode, which all three types has a mercury electrode in which there are only a minute differences all through. Why only mercury is being used up? It has a wide potential range. Okay. It gives mercury drop. Once a mercury drop falls down, a new mercury drop is regenerated over there, which serve as a new microelectrode. Thus, it inhibits electrode poisoning. What is electrode poisoning? It is the deposition of layers or ions over the surface of our electrode, which leads to false results or which can lead to inaccurate determinations because of deposition of layers over the electrode. So, this problem can be very well eradicated with our dropping mercury electrode, because every time throughout the titration, during the course of titration, a new drop is generated over there. Many metals can be widely estimated through it. It can be easily applied for the analysis of metals as zinc, cadmium, anions as bromate and iodate and carbonyl compounds such as carbonyl compound, peroxide, nitro and azo compounds, and various biochemical fluids in biochemical assays or biological fluids. So, this was all about polarography. I hope all of you understood the topic very well. Thank you.